relating topic, which is going to be presented to us by Rolf Willkrans, who is Director of Environment Affairs at Volvo Trucks. Very familiar to us, and we're very glad to have him back. He's going to be giving us an update on the implications of Vecto for heavy-duty vehicle industry, because there certainly are many implications. His view on the need for future developments to reduce CO2 and developing a certified declaration of CO2 emission standards. For those of you who don't know Rolf, he's been in his current position at the Volvo Group since 2001. He's responsible for coordination and support of product-related environmental issues within Volvo Group. He covers CO2, exhaust emissions and alternative fuels, so very much at the head of this particular topic. And he's got a Master of Science in Mechanical Engineering from Lund University. So, Rolf, welcome back, and the floor is yours. We look forward to what you have to tell us.
Thank you very much, and thank you for having me here again. It's a pleasure to be here again, and it's very nice to be in Dresden. I've never been here before, so I look forward to see a bit more about Dresden tonight. Okay, just one slide about the Volvo Group. It's a quite large company today. As you know, we focus on trucks, buses, construction vehicles, and engines for industrial and marine applications. So it's not just Volvo today. It's a lot of brands. It's Volvo, it's UD Trucks, Renault Trucks, Mack Trucks, Eicher, Dongfeng, Terex, SDLG in China, Sunwing, Prevost, Novabus, and Volvo Penta. So a lot of products, and we are selling these on 190 markets and have a net sales of about 30 billion euro. So a big company. Why is fuel efficiency important? Well, for truck hauliers, it has been and is very important due to the cost. For a long-haul application, about 30% of the cost comes from the fuel. So we have been working and are working extensively to reduce fuel consumption in the interest of lowering the cost for our customers. Greenhouse gases is of course also important, and we see some different figures about it. George has had some nearly the same figures as we have from ASEA. About 5% of the emissions in Europe comes from heavy-duty vehicles. The problem, as we see it, is that they are increasing due to the fact, due to the fact that there are so many vehicles and they are driving even longer every year. So if you look at each vehicle, it goes down, but as a complete fleet, it goes up. So we need to do something there as well. If we look at other emissions, NOx and PM, we have done a tremendous work the last 20 years there. We have reduced the emissions by almost 100%, not really, but at least 95% when it comes to PM and NOx. And we have done it with the help of legislation. We would not have been able to do this without any legislation, and that's because there isn't any real payback for the customers. It costs a lot to reduce down to the levels we have with Euro 6, I mean, it costs maybe, I don't know, several thousand of euros for each vehicle. So quite expensive, but it works very, very well today. We are very happy with the Euro 6 performance. It really works out in real traffic, so that's good. So this is an area where we really have been helped by having regulation. If we go over to then talk about certification of CO2, etc. If we started these discussions how to do this together with the Commission 2008, 2009, something like that. We started doing that. And if you look from the outside, we can say that we have two basic products. It's tractors and it's rigids. So could that be complicated to measure? Well, if we look at the usage out by the customers, then it becomes really, really complex, because almost every truck is individually built. It's just the tractors. There we have some series that looks quite the same, but when it comes to the rigids, every truck is different from each other. So it's quite a complex type of vehicle to regulate and to measure, much more complex than on the passenger car side. So when we thought about this in the industry, we said that if we would have a system for measuring this, it needs to produce values that are realistic as possible. And it must sort of reflect real driving conditions. And it must also be possible to determine these values accurately, and it should cover all the different measures and technologies that we use in order to reduce CO2 and fuel consumption. It also needs to be robust and be possible to do with a reasonable effort. And the conclusion we came to was that only full vehicle simulation-based approach will meet these targets. And the Commission listened to us, so what we ended up with is this vector simulation, and as we heard before, it is measurement of components and then calculation or simulation of the CO2 and fuel consumption for the complete vehicle. So on the left side here, we have the components, the measurements. So what we do is that we measure rolling resistance, or we don't do it, the tire manufacturers do that. And then we measure air drag, and we use standardized bodies and standardized trailers for doing that. So we measure air drag for our vehicles. We measure axle efficiency, we measure gearbox efficiency, and we measure fuel map, about 100 static points over covering the complete fuel map. And then we have auxiliaries. We don't measure those, but because there are built-in default values depending on what kind of technology we use for different auxiliaries, such as fans and compressors, etc. So what the vector then does is that it uses those standardized duty cycles. There are 5 for trucks, and we don't know how many there will be for buses, but 5 for trucks. So the simulation program looks okay. Here I should be driving in 68 kilometers. It's 1% uphill, etc. And then it goes calculate backwards. Okay, if I have this rolling resistance, this air drag, this axle efficiency, etc., I will end up in this spot in the fuel map, and here I have this specific fuel consumption. And then it moves 1 second, and it does a new calculation, and then it covers all the duty cycle and up, and as a result you get the complete fuel consumption over the duty cycle. And that is then expressed in gram per ton kilometer, gram per cubic meter kilometer, liter per 100 kilometer, etc., etc. And as we also show, there are different classes, and it's 10 different classes that are being regulated from the beginning. And it's then depending on the vehicle configuration, if it's 4x2 or 6x2, etc., and if it's rigids or tractors. So if you, for instance, have class 4, that is 4x2 rigids, then we don't know if this truck is going to be used in long haul or regional delivery or even municipal utility or refuse, actually this. So we, according to this matrix, we do calculations or simulations for all of those 3 duty cycles for a class 4 tracked, a class 4 rigid. And as you can see, there are up to 6 different, for class 11, for instance, we will do 6 calculations, simulations for each track in those classes. So it will be a lot of information. And so basically what we give to the customer is a matrix, and depending then on the vehicle class, we fill in those lines that are relevant for those classes. So we give average vehicle speed and then the CO2 emissions and fuel consumption expressed in different ways. And it will be done for a representative payload, but it will also be done for a low payload, a 10% payload. So lots of data to the customer. Can we trust these values? Yeah. First of all, this is an efficiency tool. It's a tank-to-wheel calculation. So it covers fuel consumption and tailpipe CO2. It doesn't cover renewable fuels. That is not part of this calculation. So that needs to be covered in parallel systems. And the basic thought is that it should be a comparison between different options, and it should be able to do these calculations during the sales process before the trucks are being built, in order to influence the customer specifications, etc. And the values are certified, so that sort of implies that they are true, I guess. And will they be that? Yeah, we believe that they will be very good and comparable when it comes to relative figures. Absolutely, because they are calculated and measured under similar circumstances. We use the same bodies, the same payloads, etc. So if you compare different specifications and different offers from different OEMs, yes, they will be quite good. The absolute figures, they will also be very good if you have the same payload, if you have the same road, the same driver, the same speed, etc., as being used in the simulation. Then it will be accurate, but otherwise not. So, of course, the absolute figures will not be right for each and every mission, for each and every customer. But we believe that the customers will realize this. One thing that is very important, and that is a message to the Commission, and that is we need to keep this Vector simulation program updated, because Vector will always be a little bit old. We will come with new features and new technologies, and from the beginning they will not be covered by Vector. So it's very, very important that we have a regular update of Vector. And from industry, we are of course willing to help to develop that. We have been talking about having some sort of eco-feature process. There isn't any in the regulation today, but that should be. Our thought was to have some way to represent new features and technologies that isn't part of Vector until they are being built into the simulation. Dealers, they will have a very important role because they will be the main source of information to the customers. And of course, they will work as they do today. They will specify suitable vehicles together with the customers, but then they will also be able to provide preliminary declaration values based on those specifications. And potential customers, they will of course talk to several OEMs, and they will bring results from other OEMs into this discussion and vice versa. And we also need to train the dealers in order to make them, in order to explain for customers what kind of value is this, and how is it calculated, and what does it cover and not. So dealers, they will have a very important role in this system. To conclude, we believe that this declaration regulation will reduce CO2 and fuel consumption. We actually do, because even if we have a very strong focus on fuel consumption, I've had for many years, this will make the focus even stronger on this. And the declaration values may easily be transformed into cost. You can calculate the result, and I calculate the cost for each and every customer and the differences between different specifications and offers. So it will be a tool both for the OEMs and for the customers to influence the sales process. And then maybe even more important is secondary effects. We already see and hear that different states and a lot of different stakeholders, they will use these values in order to differentiate other costs. Could be vehicle taxes, it could be road fees, it could be different criteria for procurement and environmental zones, etc., etc. And we also foresee that transport buyers, they will look into this and maybe decide that, okay, all our goods, if you should transport our goods, it must be transported by trucks having a declared value lower than XX gram per ton kilometer, etc. And that could really influence the market. Hopefully it will help our customers also to get a higher residual value if one can show that this truck has a declared value below this and that, and that's why the value of it should be higher. What's important also to think about is the cost effectiveness. Today we offer most features and technologies that are available with short payback for our customers. They are offered to the customers. All customers doesn't buy all of them, in many cases for different practical reasons, etc. And now when the declaration comes, we believe that the market uptake of these different features will go up. And we also believe that we'll be able to introduce more features with a little bit longer payback periods. That will help the CO2 emissions overall. And then when it comes to limit values, that's another story. If you have limit values, then you can sort of forget about the payback, and it can force us to introduce technologies without any payback at all, or very, very long payback. So that's the same as for NOx, for instance. We put on a lot of technology there and a lot of cost, and it doesn't have any payback really. And this is quite important when you talk about CO2 limits, we believe, because it can force us to do more and to put in more technology, but we believe that one really needs to consider the societal cost for this. What will be the cost for this abatement per kilo of CO2? There is some sort of limit where maybe we should use the money in order to reduce CO2 in other sectors. That is much less costly to do it. So one needs to think about this when it comes to the stringency of any limit values. And the increased cost needs, of course, to be transferred to the transport buyers. And if you introduce it too steeply, there is, of course, a risk to get a very low rate of fleet renewal. The customers will not buy these very expensive trucks in the beginning. So you need to consider these factors. If we should have CO2 limits, we believe that one should focus the entire vehicle, no limits on components. We should focus the complete vehicle. And we should use the vector-derived data, because there we have a very good system in order to calculate and to measure. Then we need some flexibility. We have very long product cycles in the truck industry. Our trucks, they must at least drive 1 million kilometers with just ordinary maintenance. So it's quite another business and the circumstances than for the car side. So we also need some flexibility when it comes to niche vehicles, because we have vehicles that have maybe quite high fuel consumption, but they are needed for some reasons, for very heavy loads, etc., etc. And then we need to have the scheme of this limit value regulation needs to improve real fuel consumption out on the road without any unintended consequences. Because there are risks with some of the systems that will maybe force us to do something just for fulfilling the limit values and not benefit our customers. So one needs to think this through very thoroughly. And then we talk about integrated approach. I mean, this is all vehicle-related measures, but in order to really lower the CO2 emissions from the heavy-duty vehicles, one needs to think more broadly than that. We have fleet renewal, we have alternative fuels, we have the operations, or a lot of other things that we need to work with as well in parallel with the vehicle-related measures. Just to mention the European modular systems. So up in Sweden, for instance, we can have 60-ton and 25-meter long trucks. It reduces the CO2 emissions by 10 to 15%. We've had it for many years, and that is one thing that we believe should be used in many other countries as well. So we need to have a truly integrated approach is needed in order to utilize all the possibilities that we have in the heavy-duty vehicle sector. So that was all. Thank you very much for listening.
Thank you, Rolf. Once again, we have a few minutes for questions from our speaker, and I'll start with a question. Of course, Volvo is involved globally in the truck market, particularly in North America. I'm not sure how connected you are to the US, but when you mentioned the CO2 emissions limits and the challenges there, like the unintended consequences point you made, have you seen any lessons you could draw from the North American experience with greenhouse gas regulation? The phase 1's already in place, phase 2. So there we actually have CO2 limits. What do you think has gone well, and what were the lessons to learn, if you've been involved at all?
Yeah, the phase 1 in US, the greenhouse gas regulation phase 1, that started 2014. We think it was a good way to start it, because it has now we have a system in place that works. We get all the data, the statistics where we are, what the performance are of the current products, and now they have then decided the phase 2, and they have a very good basis for setting the limits and knowing where we are regarding the performance of the vehicle. So we thought that was quite a good way to do it, and the phase 2 will be really, really challenging. So, but hopefully they have a good base for setting those limits. So we hope that we will fulfill them, and that it will help the environment, of course.
Do you see the European developments developing in a direction which will be as strict as phase 2 once we have CO2 limits?
Well, what we're a little bit afraid of is the rush, the time schedule for setting limits. We believe that one should wait for the effects of this declaration, because we do think that it will have a good effect. So we are a little bit afraid of the timing, that you set the limits without really knowing the effects of the declaration phase first.
So you think there's good reason to have a phased approach after declaration is in place? A pause?
Yeah, if we would decide how to do it, we should have the declaration for a few years first and see what happens. And then, if needed, you could go into limit values. And I mean, the whole purpose with having limit values is to go beyond these payback periods. And then you also need to, as I said, you need to compare with other sectors. We need to be careful with the money in the society at large. I mean, we need to use the resources wisely and put them in places where we can get as much CO2 reductions as possible for the resources that we use for it.
Yeah, so looking at return on investment as the measure, yeah. Any questions from the audience for Rolf? Ben has the microphone at the back. So we have a question on the left. Please, could you introduce yourself before your question? Thank you.
Thank you. Thank you for a very interesting presentation, Rolf. My question is, you were saying that there is no payback from NOx and CO2 reductions. Could you elaborate a little bit more on that?
Well, maybe it's a little blunt statement, but the transport buyers don't really demand low NOx emissions. So there isn't really a willingness to pay for that in general. That I mean, our customers, they are willing to pay for technology that lower the fuel consumption, because that lowers the cost for them. But it isn't the same for NOx, really. But of course, we believe that it's a good way to go. It's very good that we have had this legislation forcing us to introduce cleaner engines. That's very, very good for all of us. I mean, we live we all breathe the same air, and we want it to be clean.
Thank you. Ricardo Suarez from Jersey, by the way, sorry.
Oh, thank you. Any final questions for Rolf? Any final questions? Your last chance. Okay, no. Thank you again, Rolf, for the update. We appreciate it.